Now let's look at the solubility rules for various compounds. These rules will help us to decide whether a substance is soluble or insoluble in water. When we talk about the solubility rules, what we mean when we say that something is soluble is that it mostly dissolves in water. There is a limit, and that's what we call the solubility. As I mentioned before, if I put 5 pounds of sugar in 1 drop of water, it won't dissolve. But does sugar generally dissolve in water? Yes. So we would say that sugar, table sugar, is soluble in water. On the other hand, if I put an ocean of water on a little tiny rock, normally that rock would not dissolve, but with an ocean of water, parts of it might dissolve. And so we would say that that rock was insoluble, even though a little tiny bit of it might dissolve. So when we talk about soluble and insoluble, there are limits to the rules, but they basically say, if I put this in water, it does or does not dissolve. So let's look at table sugar, does dissolve in water, as you probably have seen in your life, and a rock does not dissolve in water. You can leave that rock sitting in the water for a very long time, and it will just sit there and not dissolve. And that tells us that the table sugar is soluble and the rock is insoluble in water. The first step in this process will be to decide if you have an element or a compound. Recall, elements are made up of all the same atoms, whereas compounds will have 2 or more different types of atoms present. And our first rule is going to be that all of the elements are insoluble in water. For the compounds, we have to go a little bit further. We're going to need to look at it to see if it's an ionic compound or a molecular compound. Recall that ionic compounds start with a metal or ammonium, whereas the molecular compounds start with a non-metal. Then, within each of those, we're going to want to categorize the substances as either a base or a salt, or in the molecular case, an acid or a covalent compound. And again, this will help us to identify what solubility rule to follow. And recall that bases end with hydroxide, or OH-, whereas salts end with anything else. When we look at the covalent compounds, we see that acids start with H or hydrogen, and covalent compounds start with any nonmetal other than hydrogen. Before we start, though, with the actual rules, we're going to look over a concept called like dissolves like. It's a phrase that we use to help us remember which things dissolve with which. And we'll go into more detail there, and then we'll work on how we can decide if something is soluble or insoluble. Let's look more closely at like dissolves like. We're going to be looking at both the solutes and the solvents. When we look at the solutes, there are several different types we can have. We can have a solute that is nonpolar, which we'll represent as this oval shape. We can have a solute that is polar, which will have the same oval shape, but will have a positive end and a negative end on it. Or we could have an ionic substance, in which case the solute is 2 separate pieces. One is positive and the other is negative. For the solvents, we only really look at 2 types. The solvents can be either nonpolar or polar, represented in the same way we've seen before. We're going to compare each of the solutes, see how it reacts or interacts with the solvents, and that'll determine the solubility. Looking at our like dissolves like rule, we're going to see that the solute is nonpolar and the solvent is nonpolar. Those are similar to each other, so we would say that it is soluble. The solute is soluble in the solvent. On the other hand, if we have a nonpolar solute with a polar solvent, that is insoluble because they are not like each other. Now the next one, we're going to have a polar solute, and we're going to decide which solvent does it like. Would it prefer to dissolve in the nonpolar or the polar one? And here you should see that the polar goes with the polar. So with nonpolar, it will be insoluble, and with polar, the polar solute will be soluble. And that leaves us with our ionic solutes. In the case of an ionic solute, we need to decide what is it most like. So we're going to look at the solvent, and our choices are nonpolar and polar. We do not have ionic solvents. So which one is it more like? And you should see that the ionic substance is more like a polar substance. And the more polar that substance is, the better those 2 will mix and the more soluble it'll be. But right now we know that the ionic compounds are not soluble or insoluble in nonpolar solvents, but soluble in polar solvents. So overall, we see that for the molecular compounds, the nonpolar solutes go with the nonpolar solvents, and the polar solutes go with the polar solvents. But what about the ionic compounds? Well, for the ionic compounds, as we said, they are more likely to be soluble in a polar solvent, but that does not necessarily mean that they are soluble in a polar solvent. They may be too ionic to be dissolved. Next, we'll look at the molecular compounds, and we'll be focusing on this like dissolves like rule to see how it affects the solubility of different acids and covalent compounds. Then we'll look at the ionic compounds. When we look at molecular compounds, we'll be focusing on the phrase like dissolves like that has been mentioned earlier. In the case of covalent compounds, we have two types of covalent compounds. They can be either polar or nonpolar. Because water is polar, we know that polar compounds do dissolve in polar water, whereas nonpolar compounds do not dissolve in the polar water, and so they are considered insoluble. And then we look at acids, and with acids, all of the acids are polar, and so all acids are soluble in polar water. When we look at the solubility rules for salts, we have this chart. What we will see is that salts that have any of these ions will always be soluble in water, no matter what. So we have lithium, sodium, potassium, ammonium, nitrate, or acetate, always soluble in water. For salts that have chloride, bromide, or iodide, we find that those are soluble in water unless they are linked with silver, lead 2, notice this is specifically lead 2, or with mercury. And is that mercury 1 or mercury 2? That's mercury 1. Even though it has a 2 plus charge, we see that it is still mercury 1. Okay? With those, it will be insoluble. So again, it is insoluble with silver, lead 2, and mercury 1. Now we look at the salts that have a sulfate. The sulfate ion, of course, is the anion, is going to be soluble in water unless it is with silver, the barium ion, calcium ion, and again lead 2, only lead 2. Lead 4 is still soluble. And again, for this class, we assume that all other salts are insoluble in water. This is not talking about bases yet. We'll go to that next. Before we move on to bases, let's finish up with the solubility rules by practicing what we've just learned. So how we're going to do this, my very first step, is to cut it into two parts. So we have the cation and the anion. I like to focus on those two parts first. So what I'd like you to do is split this into the two parts for all of these compounds. Please pause the video and restart when you're done. Okay, so I'm going to go through this quickly. There should be a line between the iron and the sulfur, a line between the sodium and the sulfate, a line between the barium, the phosphate, a line between the mercury and the chloride, a line between the calcium and the carbonate, a line between the lithium, the nitrate, a line between the magnesium, the acetate, a line between the lead and the chloride, and between the potassium and the oxalate. Now we want to look at the cations first. We're going to be looking for any cations that have group 1A or ammonium, specifically lithium, sodium, potassium, or ammonium in our case, but any of those will be fine. They will always be soluble, no matter what comes after it. So it could be lithium benzoate. You don't even know what benzoate is, but we know that it's soluble because it's with lithium. So let's start with that. For the moment, we're going to look at just Rule A for the cations. So looking at just the first column, which of those would be soluble? Not the first one, because it doesn't start with a group 1A. Now the second one starts with sodium, which is a group 1A ion. So we know that this will be soluble. And we're done with that one once we've identified it as soluble. And next we're going to look at the next one, which is barium. Barium's a group 2A, so we don't know yet if this is soluble or not. Next, we look at to see what anions are present. So do you see nitrate or acetate? Do you see chloride, bromide, iodide? Or do you see sulfate? If you do not see any of those, we've already gone through the first part, if you do not see any of those, then it is insoluble. So let's look at the first one. We have FeS. We already know the first part doesn't tell us anything, but the second part, is that in our list? Is it nitrate, acetate, chloride, bromide, iodide, or sulfate? Well, no, it's not. So that means it's not on our list, and so it is insoluble. How about the second one we already said is soluble. The third one, we have barium phosphate. Barium doesn't tell us anything. What about phosphate? Is phosphate on our list? No, it's not. So that one is also insoluble. All right, let's go to the second column. We look at mercury, mercury 2 chloride. So we're going to look at mercury 2 chloride, and we're going to look first, is there a group 1A ion there? And no, we do not. Mercury is not a group 1A. That means we now need to look at the anion. Now we're looking at the anion. Is it the nitrate ion, the acetate ion, chloride ion, bromide ion, iodide ion, or sulfate ion? Well, we do see that this is a chloride ion, so that means we're going to look at rule B, which says that is usually soluble. So we need to now look, is it one of the exceptions? So is mercury the exception? Well, mercury is an exception, but you read it carefully, and which mercury is it? Mercury 1 or mercury 2? Yep, it's mercury 1. Is that mercury 1 that we see in our formula? No, we see mercury 2. So this one is still soluble. Okay, let's go down to the next one. We see calcium. It is not a group 1A. Then we go to the carbonate. Is it on our list? Nope, that one is insoluble. Next one, we have lithium to start with. Lithium is a group 1A. That one is soluble. Next, we have magnesium to start with. Not a group 1A, so we have to look at the second part, and I see acetate. Acetate is always soluble, so this one is soluble. Next one, we have lead. Not a group 1A. We have chloride. Chloride is in our group B answer, so we're going to see chloride, bromide, iodide. This one's a chloride again. So is this the exception? In the exceptions, we have silver, lead 2, and mercury 1. Is this lead 2 or lead 4? That's right, this is lead 2, and so we should see that this one is insoluble. The halides are mostly soluble, but not when it's with lead 2. And our last one we have here is potassium oxalate. Potassium is a group 1A, so it is soluble. I've added 6 new compounds for you to try. These are all ionic salts, and so I want you to try them out, pause the video, and then when you come back, you'll see the answers. I'm going to start by putting the line between them so we identify our cation and our anion, and then we'll start with calcium sulfate. First, we look to see if there's a group 1A cation, and we do not see that. So that means we're going to look at the second part, the anion, which is the sulfate. Is sulfate on our list? Nitrate, acetate, chloride, bromide, iodide, or sulfate? And yes, sulfate is on our list, so we see sulfate there. And it says that it is almost always soluble unless it's with silver, barium, calcium, or lead 2. And here we do see it's with calcium, so that means it is insoluble. Next, we have a mercury with a bromine. Mercury is not a group 1A, but bromide is on our list, so we're going to see that under item B. And so we see that it says it is usually soluble unless it is with silver, lead 2, or mercury 1. So in this case, which mercury do we have? Well, the Br each has a 1 negative, total of 2 negative there. That means there's a total of 2 negative on the mercury side. There are 2 of them. That means each of those ions must be 1. We have mercury 1, and that means that this is insoluble. Let's look at lead iodide, and I'm not going to say which one it is. So we're seeing that we have a lead iodide. Lead is not a group 1A, but we do see that iodide is on our list, and it says it is usually soluble unless it's with silver, lead 2, or mercury 1. And in this case, we do not have lead 2, we have lead 4, because there's 4 negative charges for iodide. That means the lead must be a 4+. So this one would be soluble still because it is not an exception. All right, now let's go down the left-hand side, and we have aluminum nitrite. So we have aluminum, not a group 1A, but then we have nitrite. Is that on our list? We have NO3 on our list, and this is NO2. So even though there's a 3 on the outside, the ion is nitrite, not nitrate. So that means that this one is not on our list. And then it says at the very bottom, if it's not on our list, so the aluminum is not on our list, the nitrite is not on our list, then this one is insoluble because we're assuming everything else is insoluble. And next we have silver acetate. Silver is not a group 1A, but the acetate ion is on our list, and it says it is always soluble. Doesn't matter what it's with, that one is going to be soluble, so we know that that is soluble. And our last one is chromium something or other. I don't really know what it is. So it doesn't matter if you know what it is. We're going to look to see, is it on group 1A? Is chromium group 1A? Nope. All right, so then let's look at the second part. Is that one of the ions that we know? Is it nitrate, acetate, chloride, bromide, iodide, or sulfate? It is not on our list, so that means it is insoluble. I hope you got those. If not, go back and try it again. Sometimes people like to look at this in a chart form rather than in the written form you saw before. So for this, what we're going to do is we're going to look first at the cation. If it's a group 1A, ammonium, we know that it's soluble. Then second, we'll look at the anions. And finally, we'll look at the exceptions. So the only thing we have for the cations are the group 1A or ammonium. Everything else we can ignore. So if it's not a group 1A, then we have to go to the next step, part 2. And we'll see that if we see nitrate or acetate, those are always soluble. So we don't have any exceptions on those. So that's a large grouping of the ones we have. Next we have the group called the halogens, except for fluoride. And for those, they are usually soluble except for silver, lead-2, and mercury 1. So writing these formulas correctly, we're just going to go ahead and write them in. We have silver chloride, silver bromide, silver iodide, lead-2 chloride, lead-2 bromide, and lead-2 iodide. Each of those are insoluble in water. Then we can look at mercury 1 chloride, which is going to have 2 Cls, mercury 1 bromide, again 2 Brs, and mercury 1 iodide with 2 iodines. And finally we can look at the sulfates. They are almost always soluble except when they are with silver, barium, calcium, and lead-2. Notice it is lead-2 specifically. Written out in their formula, that'll be Ag2SO4, BaSO4 because barium has a 2+ charge, CaSO4, and PbSO4. So those are the formulas you'll be watching for. All of those are insoluble. And finally, if it's not on our list, what is it? That's right, it's insoluble. If you don't see it somewhere on this list, it is definitely insoluble. So now let's talk about the solubility rules for bases. In reality, we've been calling them bases, but they should be called metal hydroxides because they start with a metal and they end with a hydroxide. And of course, we're going to add in ammonium hydroxide, but we'll talk about that one later. So to decide if they're soluble, we know that they're ionic because they start with a metal or ammonium. And then in this case, we're going to end with hydroxide. That's how we identify it as a base. These rules are slightly different from the other rules. All of the previous rules we did for ionic compounds started with the substance is mostly soluble, except in this case, we're going to say that the metal hydroxides are mostly insoluble with a few exceptions. The first exceptions should be familiar to you. It ends up that the group 1A and ammonium are soluble just as they are for everything else. With the metal hydroxides, they are also soluble. So group 1A and ammonium are always soluble, even with hydroxides. Now the one that's a little bit different is the second part, and that is the group 2A. For group 2A, it is barium, calcium, and strontium that are soluble. The other parts of group 2A are not soluble, they are insoluble. I have a trick for memorizing it, and it's just for me. I remember group 2, and I say, oh, that's like channel 2, and I remember that channel 2 used to be CBS, and so I remember calcium, barium, and strontium. That's how I remember it. It helps me out. May or may not work for you, but again, it's kind of this middle section of the periodic table of group 2A. All other metal hydroxides are insoluble. So let's do an overview of those solubility rules. Remember the first step, decide if it's an element or a compound. If it's an element, we know that it is insoluble. We're done with those. Then we go into the compounds. With the compounds, you have to decide if it's an ionic compound or a molecular compound. If it's ionic, it starts with a metal. If it's molecular, it starts with a nonmetal. So we'll start there. So we'll look at the ionic compounds first. And for that, we'll have to decide if it's a base or a salt. If it's a base, it's going to end with hydroxide. If it's a salt, it ends with any other ending. And so we're going to look for the bases first. And for the bases, we're going to know that the solubility rules say it is mostly insoluble except for the group 1A and ammonium and part of 2A. And the part of 2A is this middle section where we have barium, calcium, and strontium, or I like to say it as calcium, barium, strontium. At any rate, that group 2A, part of group 2A is soluble. Later we're going to see that these are also known as our actual bases. The ones that are insoluble are going to be called insoluble metal hydroxides. All right, next let's go over to the salts. For the salts, we see that we have a lot of different choices and we need to know those rules. So I want you to have those rules remembered. We're going to start with if it has group 1A or ammonium, it's always soluble. If it has nitrate or acetate, it's always soluble. If it has a halide, so specifically chloride, bromide, and iodide, it does not include fluoride. We know that it is soluble unless it is with silver, lead 2, or mercury 1. And then we have the sulfates. The sulfates are generally soluble unless they are with silver, barium, calcium, or lead 2. And our last rule for the salts is, if it's not on this list, it is insoluble. Now let's move on to the molecules, molecular compounds. These again start with a nonmetal, and they can be divided into two classes. They can be called acids or they can be called covalent compounds. Under the acids category, remember they start with hydrogen, all acids are soluble, so that one's really easy to remember. Then we go to the covalent compounds and we have two types. We have to look at the structure to decide if the compound is polar or nonpolar. If it's polar, it's soluble, which is why the acids are soluble. And then if it's nonpolar, it is insoluble in water. And that is a review of all of the solubility rules.